In this section, we'll look at the gas supply chain. Raw natural gas goes through a number of steps before it's ready for consumption. Gas is extracted from the natural environment, usually by drilling into a natural reserve. Gas fields can be located on or offshore. Before natural gas is transported, it first must be sent to a processing plant where it can be cleaned and separated. At the processing plant, the natural gas is sent through a separator where secondary byproducts including oil, impurities, and heavier hydrocarbons such as butane, ethane, and propane are removed. Most of these byproducts are reprocessed and sent to market for other uses. As natural gas leaves the processing plant, it typically enters a compressor station where it is pressurized for transmission. This process can be done via reciprocating or centrifugal gas compressor. Typically, transmission pressure can be 10,000 kilopascals or greater. At these higher pressures, the volume of natural gas is reduced and can be transported through pipelines more efficiently. As natural gas flows through a pipeline, pressure is lost through friction. If required, gas pressure can be boosted at the compressor stations located along the transmission pipelines between a processing plant and a major demand centre where the gas is consumed. On reaching a town, major metropolitan area or industrial location, natural gas flows into a distribution pipeline network via a city gate. The city gate will reduce the transmission of gas pressure down to a few thousand kilopascals. During the process of reducing pressure, the temperature of the gas can drop to below 0 degrees. To protect against freezing pipework or liquids forming in the gas, a city gate will typically have a heater, such as a water bath heater or electrical heater, to increase the temperature of the gas. From the city gate, the gas flow is measured and the custody of the gas is transferred to a distribution company. Downstream of the city gate, gas flows through a network of smaller pipelines called mains. Even smaller lines, with progressively lower pressures, called services, branch off from the mains and go directly to the end user. The distribution company is responsible for safe and reliable transportation of the retailer's gas. The gas retailer is responsible for pricing, billing, and communication to the customer. A typical natural gas supply chain is shown in this diagram. The process starts from the gas production on the left-hand side and ends with the customers on the right-hand side. Gas is extracted from the natural environment, usually by drilling into the natural reserve. Gas fields can be located onshore or offshore. The raw gas extracted from wells typically contains quantities of water and oil in case of an associated gas. Before the gas is processed, water and oil need to be separated from the gas. Once the oil and impurities are separated, the gas will be processed further to separate the heavier hydrocarbons such as butane, ethane, and propane. Most of these byproducts are reprocessed and sent to market for other uses. Natural gas is processed to achieve pipeline quality dry natural gas. Gas quality is most commonly described based on the measurements taken of the heating value, Wabi index, oxygen levels, hydrogen sulfide concentrate, total sulfur, and so on. The higher heating value, HHV, of a gas is the amount of energy in megajoules per cubic metre released when 1 cubic metre of dry gas at standard conditions is completely burnt in air. Gases with a higher heating value, over 42.3 megajoules per cubic metre, can result in the buildup of soot on finned heat exchangers. In severe cases, soot buildup can block the flue and combustion products can spill into a building through the burner. The Wabi index of a gas is an indicator of its combustion acceptability for a given population of appliances. It is the most significant parameter in gas combustion safety. Gas with a Wabi index that is too high can result in overheating and eventual burning out or perforation of heat exchangers. It can also cause excessive carbon monoxide formation. A low Wobbe index can result in flame instability, flashback, and ignition difficulties, which may lead to flame loss and result in gas accumulations where there is no auto shut-off. Typically, the gas produced in the natural gas oil fields does not contain oxygen. When oxygen contamination is identified, the source is generally air ingress during gathering or processing. Oxygen can cause corrosion within a pipeline. At very high levels, there is the potential to form an explosive mixture. Hydrogen sulfide, or H2S, is a corrosive, poisonous gas that has a cumulative effect on pipes and copper components in gas installations. Hydrogen sulfide is also a stress-cracking agent for steel. It is a poisonous gas that can result in fatality if inhaled in high concentrations. Total sulfur is the quantity of sulfur contained in gas compounds. Some of the sulfur occurs naturally, but common odorants such as mercaptans, sulfides, and thiothenes that are added to the natural gas for safety also contain sulfur. High levels of sulfur compounds in gas increase the amount of sulfur dioxide, or SO2, created when the gas is burnt and may lead to corrosion of appliances. Sulfur compounds in the gas may lead to deposits of elemental sulfur in pipelines. The sulfur compounds may have a very strong, unpleasant smell and may lead to nuisance leak reports. Compressor stations are an integral part of the natural gas pipeline network that move the natural gas from individual producing well sites to the end user. The quantity of gas contained in a pipeline is referred to as line pack. The amount of gas in the pipeline network fluctuates throughout the day. This is because gas is injected into the system at a constant rate whilst the amount withdrawn from the system fluctuates throughout the day. As the volume of the pipeline network is fixed, the change in line pack corresponds to the change in gas pressure. Line pack is usually a maximum close at 6 a.m, depletes rapidly during the morning peak period, flattens out during the middle of the day, then depletes rapidly again during the evening peak. Natural gas is an essential feedstock for a wide range of industries and is the key to attaining the consistent high temperatures required in many sectors of the manufacturing and waste disposal industries. During the summer, when demand for natural gas is low, natural gas companies can store their excess supply. Natural gas is usually stored underground in large reservoirs. It can also be stored in liquid form known as LNG. Depleted oil or natural gas reservoirs are used as an underground storage to meet peak winter demand when production capacity may not be able to deliver the gas quantity required. There are several underground storage reservoirs in Australia, including Tubrigi Gas Station in Western Australia and Moomba Underground Gas Station in South Australia. Another method of storing gas is to convert natural gas into liquid form. By reducing its temperature to -162 degrees Celsius, natural gas can be condensed into liquefied natural gas, which takes up only 1/600th of the space it does as a gas, enabling significant quantities to be stored in a large tank. When liquefied natural gas, LNG, is ready to be used, it can be converted back to gaseous form and injected back into the pipeline network by increasing the temperature. LNG can also be transported where there is no pipeline infrastructure, domestically by truck and to export markets by ship. On reaching a town, natural gas flows into a distribution pipeline network through a city gate where its pressure is reduced, flow is measured, and custody of the gas is transferred to the distribution company. Since natural gas is colourless and odourless, mercaptan acts as an odorant to make it easier to detect. It is added as a safety measure to ensure that natural gas leaks do not go undetected. Residential customers are at the receiving end of a supply chain, using gas as fuel for heating, cooking, and other activities.